So I have printed my COVID-19 model that I made with Tinkercad here, and printed the first draft of it. It is about, I can almost get my fingers around it there. It's probably about 2 inches in diameter. I've put all the little proteins on it so that we have the 3 different varieties of protein. What I'm going to do is I'm going to rotate the proteins. The first thing I want to talk about is the fact that I like this size because my finger can fit in the gaps. If I raise it up or flatten it down, my finger can fit through the gaps of the different proteins, the protruding proteins that stick out on it. So that makes it fairly identifiable, and if I need to, it's not so bad that I can't run my finger on end through there. So we're really talking about using our finger tactually in 2 ways, using the tip of our finger to run through gaps, and using the flat of our finger similar to Braille to feel for shapes and relative position. Now there are 2 types of proteins, and I'll rotate it right here so you'll see, let me see if I can get a better one on the horizon there. There, you can kind of see it right there on the horizon. At the top are 2 little small, I believe I used octahedrons for this particular model because they would give me enough of a ridge and they wouldn't be perfectly round. The one protein is represented in the diagram on the CDC as 2 medium-sized ball-like protein bundles that are within close proximity to each other. And so these 2 are about the distance, give or take, of a .1 and .3 on a Braille cell. They're obviously a little larger. I want it to be more pronounced. And as a result, you're going to feel them really well if you go sideways across it. It's going to have an intuitive relationship that the 2 of these belong as a unit because of the relative size close to Braille. Not exactly. It is a little bigger in terms of spacing, but still well fits under your finger. Now the other protein is actually right around here around the corner. Let me see if I can rotate it so it's in the, no, I'm going to have to find another one. There are a lot of them on here. So right there, you'll see this little protein is a singular octahedral. It's smaller than the other 2. It is, oh, I'm trying to figure out where that hair, whatever it is on there is. It is protruding a lot less, but it is by itself. So if you get your finger on it, and you are touching it and it's in, say, the middle of the pad of your finger, because of the relative position of the other protein, you're not going to confuse it because you would be in contact with the other nub of the protein. So this little guy sticking up is the second protein. And then the third protein is these large protruding ones that are all over that almost make it look like I don't know. I don't even know what to describe it as, like some sort of Brillo pad. I don't know. And they are, I constructed these using a cone with 3 octahedron around the side. I didn't go for exact representation with this because I felt like the bundled protein representation is something that we can describe. And the tactual relevance of these protruding octahedron, you can feel protrusions here and there. They don't feel perfectly round. They give you something to talk about these proteins being bundled, and series of amino acids there. And so what you have are 3 distinct proteins in an orb or a globe-like COVID model. And if you wanted to, for a student who had low vision, you could paint it. I went with a straight black. This is the material I have for producing demo models, and it tends to make me focus more on the tactile sensitivity of the model. So that's my COVID-19 model. It is up on my Twitter at JackTikkun, JaQTikkun, and I hope it's useful to people. I like the way it turned out.